Welcome to this podcast on e-communications or electronic communications. This will involve a discussion about questions related to networks and to the internet in computing. These topics were from question 4 of the 2024 Computer Applications Technology or CAT November exam. And this is particularly for IEB students. There are 3 ways you can engage with the content of this podcast. If you want to test your knowledge, then download the questions covered in the video. The link is in the PDF in the video description. Then attempt these questions. And then once you've done that, come back and listen to the discussed answers and compare them with what your answers are. Or number 2, if you want to use the podcast to learn new information, then listen to the discussion first. Then download the questions from the document. The link is in the video description. And then test yourself to see how much you remember from the discussion. And the third way is to simply enjoy the discussion and learn more about e-communications. So now let's hear what our podcasters have to say on e-communications.
Okay, let's unpack this. Welcome to the deep dive. If you're a student getting into computer networking and internet tech, well, this is for you. We've gone through a whole stack of sources covering really the full spectrum, from some pretty nasty malicious software to these huge cutting-edge computing ideas.
That's right. And our mission today is to connect those dots. We want to give you a concise, essential guide to this world. We're focusing on the core security risks, the vocabulary you just have to know, and some of the efficiency hacks that make the modern web actually run.
Let's start with something everyone worries about.
Yeah.
Security. We hear the word malware all the time, but let's get specific. What about the kind of software that's designed to just lurk in the background and, watch?
You're talking about spyware, and it's one of the most insidious threats out there, mainly because it doesn't, announce itself.
It's quiet.
It's very quiet. It is malicious software that enters your computer, and its whole goal is to gather data login details, financial info, even just your browsing habits, and then send all of that to someone else without your consent.
And the really dangerous part is its ability to do something called key logging, right?
Exactly. Key logging. That's the really scary bit, isn't it?
It sounds terrifying. It's literally recording every single physical press you make on your keyboard.
Every single one. Now, here's where things get interesting, because we often mix that up with another kind of attack. How does spyware, which is so technical and silent, differ from something we all get emails about, phishing?
That's a great question. Phishing feels less like a hack and more like a con, right? A trick.
Precisely. You've hit on the key difference. It's the method of extraction. Spyware uses a technical exploit to silently steal your data. Phishing, on the other hand, is all about deception.
So it's social engineering.
It's pure social engineering. It tries to trick the victim you into voluntarily providing confidential information. It's the difference between a burglar picking your lock and a con artist convincing you to just open the door and invite them in.
That distinction is so important, and it raises a huge question for online banking. I mean, if spyware can literally record your password as you type it, how do these platforms even begin to fight back?
They have to assume a keylogger might be there. They can't just rely on a firewall. So they build defenses to make those stolen keystrokes useless.
Ow.
One of the most common methods is using something that isn't a physical keyboard, like drop-down boxes for parts of your password, or more often an on-screen virtual keyboard.
Right, the little grid of numbers and letters you click with your mouse. So why does that actually work? How does clicking a virtual key stop a keylogger?
Well, a standard keylogger is watching for the physical signal from your keyboard. A mouse click is a totally different kind of input. It's just a coordinate on the screen, so the keylogger doesn't even see it.
Ah, so you're sidestepping the entire mechanism.
You are. Now, really sophisticated malware could try to record the screen and match the coordinates, but it's a huge extra layer of complexity. Plus, the banks often randomize the layout of the keys each time.
That's smart. Okay, what about the other big one we see everywhere now? The text message with a code.
That brings us to two-factor authentication, or 2FA. This is critical, because even if a hacker gets your username and password, that information is basically useless without that second piece of the puzzle.
The code from your phone.
Exactly. It's a temporary, unique code sent to a device that only you have. The hacker might have your password on their computer somewhere else in the world, but the system needs a code that only exists on your phone, right here, right now.
And it has to be entered quickly.
Very quickly. It makes a remote attack incredibly difficult. And then, of course, the next level up is using biometrics.
A fingerprint, a face scan?
Yep. Your unique biological data, which is, theoretically impossible to hand over.
Okay, so we've built a fortress around our online identity. To really understand the web, though, we need to speak the language. Let's shift to some foundational terms, starting with the most basic identifier for any machine on a network.
Right. That would have to be the IP address. It's the unique numerical address that a network gives your computer to identify it. Think of it like a mailing address for data packets.
So it's how data knows where to go.
Yeah.
Got it. And what about the pages themselves? What are they built with?
That structure is defined by HTML, which stands for Hypertext Markup Language. It's the basic scaffolding of any web page.
And the software we use to actually see that page.
That's your browser. Chrome, Firefox, Safari. It's the application that reads the HTML and displays the page for you.
Okay, we've got location and content. Now, you mentioned spyware, tracking our habits. What's the official tool for that, the one that websites use to remember us?
That would be the cookie. It's just a small text file that a web server sends to your browser. Its job is to collect data about what you do online.
And they can be useful, right? Like keeping items in your shopping cart.
They can be, but they're also the core mechanism for advertising trackers. It's that constant trade-off between convenience and privacy.
And who is it that actually gives us access to this whole system in the first place?
That's your ISP, the Internet Service Provider, the company you pay to get a connection to the Internet.
Fantastic. So now that we have the vocabulary, let's talk efficiency. Nobody likes a slow website. We hear the term caching all the time. What is it, and why is it so important for making the web feel fast?
Caching is basically a form of high-speed temporary memory. It's a system for storing data that you use a lot. Instructions, images, even whole web pages. Somewhere local, somewhere close to you.
So it doesn't have to fetch it from far away every single time.
Exactly. The next time you request it, the system just pulls it from the local cache instantly instead of going all the way back to the original server.
So the obvious benefit is speed for me, the user. But what are the bigger system-wide benefits?
There are two huge ones. First, it massively reduces bandwidth usage across the whole network. If 1 million people want to see the same popular image, you don't need to send 1 million separate copies from the server.
The network sends it once, and then it gets cached locally for everyone else.
Precisely. And second, for the user, it means previously visited pages just load so much faster. It's all about minimizing delay and optimizing the flow of traffic.
That makes sense. But sometimes that flow just breaks. Let's talk about a real-world problem, a choppy video call, where the picture keeps freezing or breaking up. What are the real long-term solutions, not just, turn it off and on again?
Right. When video quality is consistently bad, it's usually a problem with bandwidth or network latency. A router reboot is just a temporary fix. The long-term solutions are about improving the underlying infrastructure.
Which means?
It means getting a faster connection, a higher bandwidth connection. For a lot of people, that means switching to fiber optic cable or a solid 4G or 5G connection.
And fiber's better because it's just faster.
It's faster, yes, but crucially, it has much lower latency. It uses light to transmit data, which means there's less delay, less jitter, and that's essential for smooth real-time video. A faster pipe is less likely to get congested and drop the data packets that make up the image.
Okay, so a better connection is number one. What else?
Well, you can also try to manage when you use it. If possible, connect when there's less overall internet traffic in your area. And critically, manage your own device. Make sure your conferencing software is up to date and don't overload your own connection.
Meaning close other things that are using the internet.
Yes, close background downloads, stop streaming music, shut down other tabs. You're telling your computer to give all its resources to that one important task, which helps prevent the packet loss that causes the video to break up.
That takes us from optimizing one person's connection to, well, a much bigger idea. Let's finish with this concept of grid computing. What is it?
Grid computing is a fascinating idea that really leverages the power of the network. It's about using multiple separate computers or servers and getting them to work together on a single complex problem.
How does that work?
It works by pooling all of their resources, their processing power, their memory, their storage. They all connect over a network and act as if they are one single, incredibly powerful supercomputer.
Wow, so you can tackle problems that no single machine could ever handle.
Exactly. Things like complex scientific modeling or analyzing massive data sets. It's the ultimate form of collaborative resource optimization.
Okay, let's do a quick recap for you. We've defined the silent threat of spyware versus the active deception of phishing. We talked about how online banks build a fortress with things like virtual keyboards and 2FA.
We also nailed down some core vocabulary from IP addresses to cookies, and we learned how caching is really the essential speed hack of the web.
Right, and connecting this to the bigger picture, everything we've talked about, it's all about optimizing resources, isn't it? Whether it's bandwidth or CPU cycles or your own personal data.
That's the common thread. From the speed of a cache right up to the massive scale of grid computing, it's all about using distributed resources in the smartest way possible.
Exactly. And that leaves us with one last thought for you to explore on your own. We just defined grid computing as pooling multiple computers to act as one powerful processor. So considering that frustrating issue of a choppy video call, how might that same concept resource pooling be applied to our connections themselves? Could a future network be so smart that it pools distributed bandwidth, routing traffic so intelligently that it acts like one giant congestion-free highway for everyone? Something to think about. Thank you for joining us for this deep dive.
It would mean the world to us if you could please click on that subscribe button to support the channel, and that way you won't miss when we post a new video or the rest of this podcast series or other videos that could help you. And remember, don't do it the long way, do it the Mr. Long way.